At SpaceX, simplification isn't just a design choice, it's a guiding principle that shapes every decision, from the earliest sketches of a rocket to the most ambitious plans for interplanetary travel. The company's relentless pursuit of simplicity is woven into its culture, influencing how teams approach challenges and solve problems on a daily basis. This philosophy drives decisions at every level, whether it's refining the design of a single bolt or reimagining the architecture of missions to Mars. By constantly questioning what's truly necessary, SpaceX engineers are empowered to innovate and streamline, ensuring that every element serves a clear purpose. Elon Musk's mantra is simple, yet profound. The best part is no part. The best process is no process. This mindset challenges conventional aerospace thinking, pushing the team to eliminate unnecessary complexity and focus on what truly matters. Every component, no matter how small, must justify its existence. If a part can be removed without compromising safety or performance, it's eliminated. This rigorous approach ensures that only the most essential elements remain, reducing potential points of failure. By embracing simplification, SpaceX achieves greater reliability, lowers costs, and accelerates development timelines. Fewer parts mean fewer things can go wrong, making rockets not only more affordable but also safer and easier to build. The early days of the Falcon program taught SpaceX a crucial lesson. Complexity is the enemy of reliability. Each failure and setback reinforced the importance of stripping away unnecessary systems and focusing on robust, elegant solutions. With fewer parts, the risk of failure drops dramatically. Manufacturing becomes faster and more cost-effective, allowing SpaceX to iterate quickly and launch more frequently than traditional aerospace companies. This philosophy doesn't stop at rockets. It extends to lunar and planetary missions, where SpaceX questions the need for multiple vehicles and complex transfer systems. Instead, they envision a single, versatile spacecraft capable of handling every phase of the mission. Ultimately, SpaceX's commitment to simplification is about more than engineering. It's about making space travel routine, reliable, and accessible for all. By rethinking every detail, they're laying the groundwork for humanity's future beyond Earth, one streamlined innovation at a time. SpaceX's Artemis mission plan is evolving towards a new era of simplicity and efficiency, challenging the conventions of traditional lunar exploration. The company is reimagining how humans return to the moon, focusing on streamlining every phase of the mission to reduce complexity and risk. Initially, the plan relied heavily on NASA's Orion spacecraft, which required intricate coordination and multiple complex docking maneuvers in lunar orbit. This approach, while ambitious, introduced numerous mission-critical steps, each with its own set of challenges and potential failure points. Now, SpaceX is exploring a more direct and integrated approach, proposing to eliminate Orion's role entirely. By doing so, they aim to simplify the mission architecture, making the journey to the moon more straightforward and less dependent on multiple vehicles and handoffs. In this new vision, astronauts would launch from Earth, travel to lunar orbit, land on the moon, and return, all within a single Starship vehicle. This unified system could transform lunar missions, offering a seamless experience from start to finish. By consolidating the mission into one spacecraft, SpaceX reduces the number of mission-critical systems and eliminates several risky phases, such as in-space docking and crew transfers between vehicles. This not only streamlines operations, but also enhances reliability. A single craft system offers greater safety and flexibility, allowing for rapid adjustments and fewer points of failure. The crew can remain together throughout the mission, improving communication and coordination. Fewer docking events mean fewer opportunities for things to go wrong in the unforgiving environment of deep space. This reduction in complexity is a significant step towards safer, more reliable lunar missions. Starship's full round-trip capability is still under development, with ongoing tests and prototypes pushing the boundaries of what's possible. Each milestone brings SpaceX closer to a fully reusable lunar transport system. SpaceX's ambition is to provide an end-to-end lunar service, handling every aspect of the mission, from launch to landing and return, rather than serving as just one component in a larger, more fragmented system. This shift in strategy could dramatically accelerate the timeline for establishing a sustainable human presence on the moon, paving the way for future lunar bases and long-term exploration. By prioritizing efficiency and simplicity over legacy systems, SpaceX is setting a new standard for lunar travel, focusing on what works best for the future rather than what's been done before. With this bold rethinking of mission architecture, SpaceX aims to redefine lunar exploration, making it more robust, repeatable, and accessible for generations to come. SpaceX's Starship human landing system is streamlined for simplicity. Early designs were complex, now they're cleaner and integrated. Simplified landing gear replaces retractable legs, enhancing reliability. Fewer windows prioritize structural integrity over views. The focus is on mission success and safety. SpaceX removes non-essential features for a practical lunar lander. Starship HLS evolves from sci-fi to functional equipment. It's built to work on the moon, not just visit. This transformation illustrates SpaceX's iterative design process. A bold vision becomes a reliable reality. SpaceX hones Starship for its specific lunar mission. Starship HLS's interior is meticulously crafted to balance functionality, comfort, and the unique needs of astronauts living far from Earth. Every detail, from the placement of sleeping quarters to the arrangement of workstations, is designed to support both daily routines and the psychological well-being of the crew during extended missions. The vast internal volume of Starship allows for a clear and intentional separation of living, operational, and storage areas. This thoughtful division helps reduce clutter, improve organization, and create a sense of normalcy, which is vital for long-duration missions. Practical layouts include private cabins for rest and privacy, a galley for preparing and sharing meals, and communal zones where astronauts can gather, relax, and collaborate. These spaces are designed to foster teamwork and provide personal space, both essential for crew morale. The dual-use design of Starship HLS means it can efficiently support both small crews on short missions and larger teams establishing lunar bases. Its modular approach allows for adaptability, making it suitable for a variety of mission profiles and future expansion. An innovative internal elevator system ensures astronauts can safely and easily move between the spacecraft's decks and access the lunar surface, even while wearing bulky spacesuits. This feature enhances safety and accessibility for all crew members. Starship is more than just a lunar lander, it's a true habitat, designed to support astronauts as they live, work, and thrive in space for weeks or even months at a time. With a larger usable volume than the International Space Station, Starship offers unprecedented space for movement, storage, and scientific research, making life in space more comfortable and productive. This leap in design transforms lunar exploration from a series of brief visits into the possibility of a truly sustainable human presence, where crews can live and work on the moon for extended periods. Starship is purpose-built for long-term habitation, supporting not just survival, but a high quality of life, with amenities and systems that enable extended missions and ongoing scientific discovery. Ultimately, SpaceX's ambitions reach far beyond the moon. Starship is a stepping stone toward a permanent human presence in deep space, paving the way for future missions to Mars and beyond, and redefining what's possible for humanity's future among the stars. SpaceX's path to a lunar-capable Starship involves key milestones. High-altitude tests provide data on controls and performance. Orbital refueling is crucial for lunar missions. A tanker Starship will refuel the lunar-bound Starship in orbit. This technology is essential for deep space ambitions. An uncrewed lunar landing will test navigation and landing systems. Each test flight informs design improvements. Rapid iteration accelerates progress towards lunar readiness. Achieving orbit, refueling, and landing are key steps. SpaceX's fast-paced testing builds confidence in overcoming challenges. The goal boots back on the lunar surface. NASA awarded SpaceX the lunar lander contract but remains cautious. Concerns about SpaceX's timeline and unproven technologies persist. NASA seeks a second provider, creating competition with Blue Origin. Blue Origin's traditional approach contrasts with SpaceX's innovation. Competition spurs innovation and cost reduction. SpaceX thrives under pressure, aiming to prove doubters wrong. Success hinges on executing their plan: orbit, refuel, land. Scrutiny reinforces the need for a robust design. SpaceX's simplified approach must perform as promised. SpaceX's operational philosophy sets it apart in the lunar race. Speed, transparency, and rapid iteration define their progress. Concurrent building and testing generate real-world data quickly. Public testing and updates build engagement and accountability. Rapid iteration embraces failure, as a learning tool. Starship prototypes evolve swiftly through testing cycles. Simplified architecture accelerates development and testing. SpaceX's methodology tackles engineering challenges efficiently. Their strategic advantage lies in this unique approach. SpaceX aims to deliver a lunar landing system sooner and cheaper. Starship HLS simplification is a step towards Mars colonization. The Moon is a testing ground for Mars systems and procedures. Direct Earth-to-Moon architecture mirrors future Mars missions. Orbital refueling practice prepares for interplanetary journeys. Starship's multi-purpose design supports solar system exploration. A fleet could establish a sustainable Earth-Moon logistics chain. SpaceX's lunar missions are a prelude to Mars colonization. The streamlined Starship HLS is the first step to another planet.